Okay. All right, guys. So once again, we're finding the zeros of the polynomials, guys. So we're starting off with this polynomial right here. It's a 4th degree polynomial. Just a few things to recap from the previous video, especially if you did not watch the previous video yet, okay? The degree of this polynomial, the highest power typically, is 4, okay? The degree is 4. Now, the degree is also a maximum, it also indicates the maximum number of solutions, max number of solutions, max number of solutions. As well as, guys, it helps you to determine your turning points. If you were to graph this polynomial right here, the number of turning points, if we call the degree n, would equal to, would be at most, is at most the degree, which we're going to call n, minus 1. So if we were to graph this 4th degree polynomial, at most, this 4th degree polynomial will have 3 turning points. By the way, guys, as we go further into the higher degree polynomials, the higher degree polynomials start mimicking each other. So a 4th degree polynomial graph might actually look like a quadratic, a 2nd degree graph. And likewise, a 5th degree polynomial graph might look like a 3rd degree polynomial graph, which reminds me, guys, there's one problem on the assignments where you are asked to graph a 3rd degree polynomial and they want you to find all the zeros of the polynomial as well as the y-intercept. So that one right there, unlike all the other graphs you have to do for this class, it requires more than 2 points. Typically when you graph in my math lab, you need 2 points. But that 3rd degree polynomial requires all the zeros. Those are the x-intercepts. And I'll show you how to find those x-intercepts. You know, it's a 3rd degree polynomial, so you could factor it by grouping. And then they also want you to find the y-intercept. And you know how to find the y-intercept. You plug in 0 for the function and solve it out. That's how you find your y-intercept. So you plot the y-intercept, plot the x-intercepts, and it will generate the 3rd degree polynomial for you. By the way, the other thing that was on the other video was the end behavior of these graphs, how the graphs behave at the extreme values, okay? As x is increasing, as x is decreasing, what's happening to the y values, okay? That's in the previous video, guys. So anyways, getting back to this, guys. So our goal right here is to focus on finding the zeros. By the way, we could use the graphing, which is what we're going to talk about with the calculator portion of this class, to help us figure out some of these zeros. Sometimes the calculator will give you all the zeros, but there are times when you will not be able to utilize the calculator to get all the zeros. By the way, while I'm on the calculator, guys, so far the most powerful graphing calculator we have that's available on the market is a TI Titanium, 89 Titanium, designed for engineers. So my engineer majors, okay, they're not allowed at this level, but once you get into calculus for engineers, you're allowed to use a TI-89 Titanium. And that one right here, it costs $150, but guys, it's so powerful. You can type in problems like that into the calculator and it gives you all the solutions, even if they're not exact solutions. Yes. All right, so I am going to get back to this problem. That was a lot of talking, Shazam. Okay, let me go ahead and get into the problem, guys. So listen, guys, I am going to go through some steps. So pay careful attention, okay? And like I said, this problem is going to be very long, okay? So guys, the first step, step number 1, is to list all the possible rational zeros, of the polynomial, rational zeros of the polynomial. Okay. By the way, sometimes I write zeros with ES and sometimes I just put on S in there. Both of them are acceptable. Okay. List all the possible rational zeros of the polynomial. By the way, what allows us to do this, guys, is the rational zero theorem. Okay. The rational zero theorem. I don't mention the zeros that much, but if you want to know which theorem it is, it's the rational zero theorem. So essentially what you're doing is you listing all the possible values that the zeros of this polynomial could potentially be. So what are they? You're going to list factors of, they're going to include factors of C. C stands for the constant. And factors of C over A. as in the constant divided by the leading coefficient. In the case of our polynomial here, guys, okay, x to the fourth minus 6x squared minus 8x, and then plus the 24 equals to 0, our C value for this problem is the 24. That's our C value. So we're going to list all the factors of C, guys. By the way, there's questions like this on the assignment too, okay? Where they're asking you to list all the possible rational zeros or all the possible rational factors, okay? Now, for this one here, guys, we're going to find all the numbers that can go into 24 evenly. So, including the positives as well as the negatives. So plus or minus 1, plus or minus 2, every single number that divides into 24 evenly, every factor of 24, guys. Plus or minus 3, plus or minus 4, plus or minus 6, and yes, the list keeps going. Plus or minus 12, plus or minus, what else? 24. Yeah. Now, guys, additionally, you have to take the A value into consideration. Now, for this problem, the A value is the number in front of the term with the highest power. The term with the highest power is x to the fourth. Its coefficient is 1. So if you were to take each factor of 24 and divide it by the leading coefficient, which is 1, you're going to get the exact same set of factors back. So in the case of this one, guys, listen, what I'm trying to tell you is this. You do not have any C over A to worry about. So the list of possible rational zeros would be all of this. And that would be the answer. Now, when you're typing this in, guys, please double check it. Make sure you put in those commas. You do have the plus or minus symbol on the tools palette, so make sure you utilize that to type in all these possible rational zeros. All right, so that one was totally easy. So let me do one that's similar to what you might see on the test. And this one right here is f of x equals to 3x to the fourth plus 2x to the second plus 5. Now, this is an example of a problem you could encounter on the test as well as on the final exam. Remember, guys, the 4 tests and the final exam will be administered in the classroom, unless, of course, something, no, let's not put it there. Ooh, 2020 has been too much. Shazam. So, guys, let's go ahead and do it. So we're going to list the factors of C. What's the C value for this one? The C value for this one is going to be 5. All right, so we're going to list all the factors of 5. The factors of 5, numbers that go into 5 are plus or minus 1, plus or minus 5. And there you go. But we also have to take into consideration C over A. Now, why? Because our leading coefficient, guys, is not 1, it's 3. So it is going to affect our factors, okay? So for the C over A, look at the factors of A. What are the factors of A? I'm going to decide with this because the A value is 3. We're not going to include that as part of the list of possible rational zeros, okay? So that's why I'm going to go to the side. They are plus or minus 1, plus or minus 3. Now, here's the C over A, guys. We take each factor from 5 and divide it by each factor of A. So if we take plus or minus 1, plus or minus 5, we divide by 1, we get the same set of factors back. But if we take plus or minus 1, we divide it by 3, we get a brand new set of factors, guys, plus or minus 1/3. Likewise, if we take plus or minus 5 and divide it by 3, we get a brand new set of factors. So plus or minus 5 over 3. So for all the possible rational zeros, the list will include, guys, all of these. So this would reflect all the possibilities for the zeros of this polynomial. All right, so I want you to take a moment, look at this one, guys. If you were to see it on the test, would you be able to do it? Would you be able to come up with that list? That's the question you have to ask yourself. If you can't, you need to ask me a question. If you want me to clarify something, let me know. Anything? All right, guys. So I'm just gonna keep going. Here comes, that, by the way, that was just step 1. Here comes step 2, everybody. Now, step number 2, we are going to test each zero one at a time to find at least one zero or a zero of the polynomial. Okay, so guys, what do I mean by testing each of these zeros? You got to take each number one at a time, go back into the polynomial and plug them in. Just to recap, we're still using that same fourth degree polynomial, x to the fourth. What was it? Minus 6x squared minus 8x plus 24. And then some of the possible rational zeros were plus or minus 1, plus or minus 2, plus or minus 3. Okay, I'm going to stop right here and ellipsis this out. Okay, now guys, listen, we got to test these one at a time. This is where the graphing calculator actually helps with the process. So if you had a graphing calculator, you would go ahead and go into your Y editing screen and type in the equation, hit graph, so you can see if the graph is intersecting the x-axis. Go to the table and verify those zeros, okay? And then use those zeros to help you efficiently solve the problem, okay? So in this case, we're not doing this with a graphing calculator, so we're going to go ahead and test the zeros one at a time. So guys, here's how you test it. Starting with +1, we're gonna take +1, plug it into the function, plug it into that equation for every single x. What are we looking for? We're looking for at least one value that makes the polynomial equal out to 0. So guys, let's go ahead and give it a try. Now, first and foremost, with the 1, -1, I want you to do some brainstorming, guys. Eyeball this. If I plug in 1 into the first term, 1 into the second term, 1 into the third term, and then add it all up together, there's no way that's going to give me 0. So I don't think the 1, -1 is going to work, okay? So I'm gonna go to 2. I'm gonna try 2. If the solution was 2, okay? It has to make the polynomial equal out to 0. So let's go ahead and give it a try. We'll plug in 2 into the polynomial for every single x and working it out. What are we looking for? To check to see if it makes the polynomial equal out to 0. So this gives you 16. 2 squared is 4. 4 times 6 is 24. 8 times 2 is 16, and then plus 24. Shazam! Look at that, guys. 16 takes away 16, -24 plus 24, and bam, it works out the 2. Yes, works. Okay? So now, guys, we found one of the zeros. So now we can move on to the next step. One of the zeros is x equals to 2. So here comes step number 3. By the way, you can check the other zeros as well to see if you can find one more. It does help to find 2 preferably, but if you can find 1, you're good to go. All right, guys. So we're gonna move on to step number 3. So here comes step number 3. Step number 3, you're going to now use synthetic division. Carry out synthetic division with the 0 that you just found. The 0 that you just found, guys, okay? And what are you looking for? To find the quotient. What's the quotient? The quotient is the answer to a division algorithm, guys, okay? So now, once you find the quotient, you are to take the quotient, set the quotient equal to 0, and solve to find the remaining zeros of the polynomial. What if you can't solve it, guys? If not possible, you're going to have to, and here's the key part, guys. If not possible, you're going to have to repeat steps 2, 3, and 4. I know, okay? Yeah. So guys, let's go ahead and give it a try. So we found a 0, which was 2. So that's going to become our divisor for our synthetic division. So we're going to take the 2 and divide it synthetically into the polynomial. So we grab the coefficients of each term of the polynomial. Now guys, remember synthetic division is in the previous video if you haven't watched it, okay? So now guys, I'm going to list the coefficients of every single term. By the way, I'm just gonna write the polynomial down here so you can see it as I talk about it, okay? X to the 4th minus 6x squared minus 8x plus 24. I'll erase it in a minute. The coefficient of x to the fourth, guys, is 1. We don't have an x to the third power. If you're missing a term or a power, you have to fill in a 0 for it. So we're going to fill in a 0 for the x cubed because it's missing. The next term down is the x squared term, and it's got a coefficient of -6. Next term down is x to the first power. It's got a coefficient of -8. Then finally, you have your constant, okay? So guys, this would reflect our values, the coefficients of the polynomial, and this would be our setup for synthetic division. So now that we have our setup for the synthetic division, we're going to carry out the process. By the way, the process for synthetic division is bring down the first term, multiply, add, and then repeat all over again, okay? So guys, here it is. I'm just gonna go on a limb here and say some of you did not watch the video. So I'm gonna take my time going over this, okay? So I'm gonna bring down the 1, guys. And then I'm gonna take that 1 below the line and multiply it by the divisor. 1 times 2 is 2. The 2 goes above the line, and then I'm gonna add. So 0 plus 2 is 2. I'm gonna repeat the process all over again. So I am going to now take that 2, and I am going to multiply it by the divisor. So 2 times 2 is going to give me what? It's gonna give me 4. And that 4, guys, is going to go above the line, right here below the -6. Now I'm gonna add again. -6 plus 4 is -2. And I'm gonna keep repeating the process until I'm done. So -2 times 2, the divisor, that's going to give me a -4. I'm gonna add, so I get a -12. -12 times 2 is going to give me a -24, guys. And when I add, I get 0. By the way, this is expected. This represents your remainder. And of course, it has to be 0. Why? Because 2 is a 0 of the polynomial. Of course, the remainder must be 0. If it's a factor, if it's a 0 of the polynomial, when you divide it synthetically, the remainder must be 0, guys. And by the way, that's also included in the last video, guys, okay? So what do we have here? We're going to have the quotient. So when it's time to create the quotient, to write out the quotient, guys, you got to go back in and fill in your variables. The original polynomial was a 4th degree polynomial. So when we start filling in the variables, we start with a power less than the original polynomial. It was a 4th degree polynomial. So when we start filling in the variables, we start with 1 degree less. So we're going to start with x to the 3rd and then move forward in descending order of powers until we've run out of x's. So basically our quotient would be x cubed plus 2x squared minus 2x minus 12. I don't have sufficient room to write it down here. That's why I'm not writing it. So what I'm going to do is erase this so I can go to the next step. All right, guys. So our quotient turned out to be x squared plus 2x, x cubed plus 2x squared, and then minus 2x minus 12. Now remember, the next step says set it equal to 0 and try to solve this. Now guys, this is a 3rd degree polynomial. It's got 4 terms. Can we solve this by grouping? Absolutely not. If you were to group the first 2 terms, the GCF would be x squared. That would leave you with x plus 2. But if you group the last 2 terms, the GCF would be a -2, and that would leave you with x plus 6. And that one makes sense. So since you cannot factor this, you cannot solve it, you cannot factor it to solve it, guess what? You're going to have to repeat the process, guys. Yeah. We're going to have to go back and test those zeros again. What are the zeros again? The possible rational zeros, plus or minus 1, plus or minus 2, plus or minus 3, and so forth and so on from the beginning of the problem, guys. We're going to have to redo steps 2, 3, and 4, okay? Remember, these are higher degree polynomials that cannot be factored, so we are using synthetic division to help us solve these higher degree polynomials, okay? So now, guys, just eyeball this. Let's go ahead and brainstorm this. If we were to take +1 or -1 and plug it into each term of this polynomial, this 3rd degree polynomial, would it zero out? No, it will not zero out, because if you plug it into the first term, you get 1, the second term gives you 2, the third term gives you a -2, and then minus 12. That's not gonna zero out. So guys, this doesn't work. So let's go to the 2. So if we plug in 2 for every single x in here, let's see what happens, people. Let's see what happens. Okay, 2 cubed is 8, 2 squared is 4, 4 times 2 is another 8, 2 times 2 is 4, and then minus 12. Now guys, 16 minus 4 minus 12, guess what? It zeroes out. So yes, x equals to 2 is a 0 of this polynomial. So now what do we have to do? Divide it synthetically. So we're going to go into synthetic division again. Now we're going to do it with the 3rd degree polynomial. The coefficient of x to the 3rd power, guys, the coefficient is 1. Okay. Coefficient of x squared is 2. Coefficient of x is -2. And then finally, we've got -12. Now, I am going to draw my line, carry out the process. So guys, here we go. I'm going to bring down the 1, multiply it by the divisor. Now I'm gonna add, so I get 4. 4 times 2 is 8. I'm gonna add, I get 6. 6 times 2 is 12. I add, I get 0. And that's expected because 2 is a 0 of the polynomial. So now I am going to fill in my variables. Remember, this was a 3rd degree polynomial. So when I start filling in the variables, I start with a power or a degree less than the original polynomial. So I'm starting off with x squared followed by x. I've run out of x's, so I need to stop writing. So my quotient for this problem is x to the 2nd plus 4x plus 6. And then now you're supposed to set this equal to 0 and solve it. Now, here's a big question. This is a 2nd degree equation, guys. This is what we are really good at. This is where we are an expert at solving 2nd degree equation. Everybody can solve a 2nd degree equation. How do we solve a 2nd degree equation? Think about that for a minute. You can drop some of the methods in the chat, guys. How do we solve a 2nd degree equation? Because now we have to solve the 2nd degree equation. How? What methods do we use to solve a 2nd degree equation? Anybody? Come on, people. Anybody? Factor, quadratic formula. I see you. Very good. One more. I know you guys don't want to say it, but you should say it. Because it's efficient, guys. Not grouping. You can't do grouping on this one. Yes, yes, I just saw it. Somebody said it. Oh, Samantha says, oh, complete the square. Yes, complete the square. Who said that one? Let me see who said it. Oh, that was Jaden. Very good, Jaden. Okay, Jaden said complete the square because that's exactly what we're going to use. So guys, when solving these 2nd degree quadratics, yes, you could factor, but this one right here is not factorable. Yeah, but it only works for some of them, Samantha. Grouping doesn't work for all of them, okay? Like the 3rd degree polynomial, yes, it had 4 terms. You could try and factor it by grouping, but it won't work out, okay? So factoring will not work out for this one, guys. Now, quadratic formula will work out, but it's too long, guys, okay? The quadratic formula, that's too long. But let me tell you, completing the square is very efficient, guys. So we are going to use completing the square. Remember, I told you guys, completing the square is best used when the leading coefficient is equal to 1 and the b term is even. This is the ideal candidate for completing the square. I never told you guys this. I never mentioned in this class, but what I usually tell students is this. If you don't get completing the square in chapter 1, you will get it by the end of this class, because remember, we used it in chapter 2 to write the equations of the circles in standard form. Here we are again using it. We could also use completing the square to transform a quadratic equation into standard form as well. So guys, listen, you will learn completing the square. So let's practice, okay? So guys, we're gonna complete the square with this. First, I am moving the 6 over to the right side, so it'll become a -6. Second, I am going to do I'm going to complete the square by taking half of 4, which is 2. I'm gonna take my 2 and square it, so that's gonna give me 4. So I'm gonna add 4 to both sides. Add 4 to both sides. You know what? Let me go ahead and underline this with some red. okay? So now, guys, on the right side, this will become -2. On the left side, we're going to factor this into a binomial square, because when you factor x squared plus 4x plus 4, it factors into two identical binomials, x plus 2, x plus 2. So we're going to do x plus 2 squared. By the way, here's a little trick. Take an x from the x squared, take half of the 4, okay? And that's how you get your x plus 2 squared. So now, guys, it's in that form where you could just go ahead and solve it by taking the square root of both sides. Remember, when you take the square root of a negative, it becomes an imaginary unit. And then the last step is to take this 2, move it over to the other side. So here's the final answer, -2 plus or minus I radical 2. That's just for the quadratic. But what about the entire problem, guys? So what's the solution set for the entire problem? So guys, here's the outcome for that 4th degree polynomial. We had 2 guys, which we used twice. By the way, that's called a multiplicity of 2. That was in the last video. I hope you guys are watching the videos, okay? And it does help, guys, okay? And then we have another set of solutions, -2 plus or minus I radical 2. So this is the outcome for that 4th degree polynomial. And yes, guys, you will get one of these on the test. Now, we ended up with one real value, okay, which has a multiplicity of 2. And then we ended up with 2 complex solutions. Remember, at the beginning of this lesson, I said the degree is an indication of the max number of solutions. Maximum. Did we get the max here? No, we actually got 3 solutions. 2 and a -2 plus or minus I radical 2 accounts for the other 2 solutions. Yep. All right, guys. Yeah, that was a long one, okay? So let me go ahead and do another one. This is on the test. Yeah, these problems are very long, okay? Normally, if I was in the classroom with you, I would tell you, grab your graphing. Actually, you know what? Some of you have graphing calculator. Raise your hand if you have a graphing calculator in your possession. If you have one in your possession, on your iPhones or on your Android devices, okay? Go ahead and type this problem, guys, into the Y editing screen, okay? Just type it in there. And then the next thing you should do is hit graph to see if the graph intersects the x-axis. And if it does intersect the x-axis, where does it intersect the x-axis as? Remember, the zeros, the roots, the solutions are the x-intercepts. Now, for you to verify that they are truly the zeros or the solutions to the problem, you want to go to the table. When you go to the table, what are you looking for? Everywhere on the table y is 0, the corresponding x value is the 0 of the polynomial. So guys, if you got a graphing calculator in possession, yeah, type it into the graphing calculator. This is supposed to help you. I am going to be talking about the graphing calculator very shortly, but for now, guys, I am just going through the problem, okay? This one is going to take less time because I'm not explaining the information anymore. So guys, here we go. So we're gonna list the possible rational zeros. Did you put the attendance code? No, not yet. Now, the C value, guys, we're going to list the factors of C, plus or minus 1, plus or minus 2, plus or minus 4. Every single value that goes into 4. Now, we're going to test the zeros one at a time. So let's start with x equals to 1. If x were to equal to 1, we should go into the polynomial, substitute 1 in for every single x value. Does it simplify the problem out? All right, guys, so let's look. We get 1 minus 2 minus 5 plus 8 plus 4. Well, is this one gonna work out? I don't think it's gonna work out, guys. 1 minus 2 is -1, -1 minus 5. Nope, that doesn't work out, guys. It doesn't work out. So let's try the next one. Let's try -1. I don't think the -1 is gonna work either. So I'm gonna move on to 2. Okay, so let's try 2. So we're gonna do 2 to the 4th minus 2 to the 3rd. Samantha, did you get the answers yet? Now, you didn't get anything? No x-intercepts, or are you having a difficult time typing it in? All right, so guys, 2 to the 4th, 16. 2 to the 3rd times 2, that's also going to be 16. 2 squared is 4, 4 times 5 is 20. 8 times 2 is 16, and then plus 4. So 16 takes away 16. Negative 20 plus 16 is negative 4. Negative 4 plus 4 is 0. So it works, guys. Okay, so this one works. I might as well, since I can do synthetic division right here anyways, I might as well try the negative 2. Let's give it a try. Negative 2 to the 4th power minus 2 times negative 2 cubed minus 5 times negative 2 squared, and then plus 8 times negative 2, and then finally plus 4. Let's work it out. Negative 2 to the 4th, that's 16. Negative 2 to the 3rd is negative 8. Negative 8 times negative 2 is positive 16. Negative 2 to the 2nd is 4. 4 times negative 5 is going to be a negative 20. 8 times negative 2, guys, is negative 16, and then plus 4. So essentially, 16 cancels out negative 16. 16 minus 20 is negative 4. Negative 4 plus 4 is 0. So this one works out too. So guys, what just happened? I found 2 zeros of this 4th degree polynomial. Since the max number of solutions we can find for this problem is 4, how many more zeros of this polynomial are we looking for, guys? We already found 2. So we're missing up to 2 more. So now we're going to carry out synthetic division to find the remaining zeros, guys. And I'm going to give you some shortcuts too as we go through this. I'm just going to go ahead and erase this part so I don't have to erase the entire problem all over again. Remember the 2 zeros, guys, okay? This takes forever for me to figure out this way. Yeah, but I don't want to rewrite the polynomial. I think it would have been easier to just erase the entire thing and just rewrite the polynomial Shazam. Okay. All right. Anyways, guys, here we go. All right. So I'm going to start off. My 2 zeros are x equals to 2 or x equals to negative 2. That's my zeros. So now I'm going to choose one of them. It doesn't matter which one, guys. Carry out synthetic division. All right. So the coefficient of x to the 4th is 1. Coefficient of x cubed is negative 2. Don't forget the negatives. Coefficient of x squared is negative 5. Descending order of powers, guys. Coefficient of x is 8. And then finally the constant term. So now we're going to carry out our synthetic division. So drop the 1. 1 times 2 is 2. We add. We get 0. We're adding over here. 0 times 2 is 0. We add. We get negative 5. Negative 5 times 2 is a negative 10. We add. We get negative 2. Negative 2 times 2 is going to be a negative 4. We add. We get 0. That was expected. Now, guys, here's a shortcut, okay? Rather than having to write out the quotient, go straight into the second synthetic division. Right here, guys. Now, I'm going to go ahead and divide with the negative 2. Yeah, go straight into the second synthetic division. So we're going to drop the 1. 1 times negative 2 is negative 2. Okay, so we're going to add 0 plus negative 2 is negative 2. And then negative 2 times negative 2 is 4. We add, we get negative 1. Negative 1 times negative 2 is positive 2. We add, we get 0. This was expected. So now, guys, we can finally fill in the variables. Now, what just happened? This is what just happened, guys. I just did synthetic division twice using the 2 zeros. So the first time I did the synthetic division, it reduced the 4th degree polynomial down to a 3rd degree polynomial. And then the second time I did the synthetic division, it reduces the 3rd degree polynomial down to a 2nd degree polynomial. So I went from 4th degree to 3rd degree to 2nd degree. And once we get to that 2nd degree polynomial, guys, it's so easy to go ahead and solve. Anybody can solve a 2nd degree polynomial, okay? So now you see, this is not as long as it was earlier because we're finding shortcuts and we're going through it a little faster. And so this is a bit more efficient than the first one we did. So now, guys, I am going to solve the 2nd degree equation. so I can find the remaining zeros. So I'm going to take that x squared minus 2x minus 1, set it equal to 0, and solve. Is this a good candidate for completing the square? Absolutely. So we're going to take that -1, move it over to the right. That's the same thing as adding to both sides. Then we're going to take half of -2, which is -1. We're going to square it and add it to both sides. Once again, I did half of -2. That's -1. By the way, you don't even have to worry about the negative. You square it, you get +1. On the left side, I'm going to factor it. I'm going to take an x on the x squared, half of the -2. Ooh, did you guys see that I put a plus there? That's supposed to be a minus. Half of -2 is 1, and then 1 plus 1 is 2. And now I'm going to finish solving it by using the square root property. So I end up with x minus 1 is equal to plus or minus radical 2. And then the last step is to add the 1 to both sides, which is the same thing as moving it over. So guys, I end up with x equals 1 plus or minus radical 2. All right, guys, we're done with the problem. We just need to express the solution. So what's the solution for this one? We have 2 exact values, 2, -2, and then 2 irrational values. There's the outcome for the fourth degree polynomial. Guys, that's it. Any questions? No? I know, it might be a bit overwhelming to you. Why don't we test 4? We could, but as you can see, the answer ends up in 2 exact zeros and then 2 irrational zeros. So there's really no point. Can we try one? Yes, Jesse, you're welcome to try one. Now, listen, the reason why I stopped at 2, -2 is because when you do these problems, if you can find 2 solid zeros for a fourth degree polynomial, it's a really good start. You just need 1, but if you can find 2, that's even better for a fourth degree polynomial. Because by finding 2, you know you're automatically going to reduce that to a second degree polynomial using synthetic division. And it's very easy to solve a second degree polynomial. So you don't have to go past 2, okay? All right, guys. So somebody said, can I try one? Sure. All right, here it is, guys. This one is f of x is equal to x to the 4th minus 2x cubed plus x squared plus 12x plus 8. All right, guys. Sure, go ahead and give this one a try. And yes, this is a fourth degree polynomial. So the first thing you need to look for are those real zeros. If you have a graphing calculator, plug it into your graphing calculator. See what happens. Now, if you don't have a graphing calculator, what are you going to do? You're going to list all the factors of 8. As in plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And then test them one at a time. All right, guys, so the aim is to take the test, the chapter 3 test, on the 5th of November. 5th of November, guys. Election week. All right, how you guys doing? Now, those of you who typed it into the graphing calculator, did anybody find it? There was a lot of room for error, but I got it. You're right. Moria, you absolutely right. By the way, for me, when I was going through these classes in college, these were my favorite problems. The problems that took a whole page or 2 pages, these were my favorite problems. Like, I fell in love, I really fell in love with math when I saw the quadratic formula for the first time. Oh my God, I fell in love. Okay, that was too much personal information. TMI. All right, so did you guys find any of the real zeros? Nobody? As in, if you graph this polynomial, do you see where the graph is intersecting the x-axis? No one? Okay, so then let's give it a try, guys. Let's test the zeros, okay? So on this one right here, I'm confused to where you got, all right, I'm confused to where you got the red numbers. I came in late. All right, that's the factors of 8, the C value. The C is the constant. C is always referred to as the constant. And so I listed the factors of C. Every single number that goes into 8 evenly. That's what the red numbers are. All right, guys. So let's test out the 1. Let me go ahead and plug in 1 for every single x and see what happens, guys. Does it work out? Ooh, I don't think it's gonna work out, guys. Ooh, this is all addition. So this one doesn't work out. Let's try -1. For the -1 to the 4th minus 2 times -1 cubed plus -1 squared plus 12 times -1 and then plus 8. Well, this is going to be a positive 1. This is going to be a positive 2. -1 squared is 1. 12 times -1 is -12 and then plus 8. 1 plus 2 plus 1 is 4. 4 minus 12 is -8. -8 plus 8 is 0. So the -1 works. All right. So nobody's typing these into the graphing calculator? Okay, guys. So let's go ahead and start with that. Now, I could do some additional numbers, but I'm looking at the 2 and the -2. I don't think they're going to work out. So I think I'm just going to go ahead and move on with the -1 and start doing my synthetic division, guys. So we know if it works. Let me see. Hold on. We know if it works or not, if it equals to 0. Yes, that's the whole purpose. We're looking for zeros of the polynomial. So when you plug in those values, they have to make the polynomial equal out to 0. Yeah. All right, guys. So let's go ahead and do synthetic division. 1 is the coefficient of x to the 4th. Your graphing calculator is whack. Okay, I'll help you with it in a little bit, okay? X to the 4th, its coefficient is 1. Coefficient of x cubed is -2. Coefficient of x squared is 1. And then coefficient of x is 12, guys. And then finally, we have the 8. You know what? Let me put this closer to this 1 here. I don't want you guys thinking that's 2 separate numbers. There we go. So we got the coefficients of every single term. Oh, very good, Jessica. Yes, it says -1 works. But do you notice anything interesting about the graph at -1? Is the graph crossing or is it touching the x-axis? Is it bouncing on the x-axis or is it going straight through the x-axis and ending up on the other side into the negative side of the y-axis? Or the other way around, whatever. Yeah, what is it doing? So based on what it is doing, that determines what's happening. Yes, it is touching, Jessica. So what does that mean? That the -2 is going to represent 2 solutions. It has a multiplicity of 2. It's repeating twice. It's representing 2 solutions of this polynomial. So which means once we're done with the synthetic division, we could go straight into a second synthetic division with -1 again. That's what that means. It's a repeated 0. It's a repeated 0 of the polynomial. Okay, very good, Jessica, very good. All right, guys, so let me go ahead and do this one out. Drop the 1. 1 times -1 is -1. We add, we get -3. -3 times -1 is +3. We add, we get 4. 4 times -1 is -4. We add 12 plus -4 is 8. 8 times -1 gives us a -8, guys. We add, we got the 0. Again, another way to confirm that, yes, guys, we're doing this. We're on the right path. -1 is definitely a 0 because the remainder is 0. So since Jessica said the -1 has a multiplicity of 2, as in the graph, if you're looking at the graph, the graph is touching or bouncing at x equals to -1, we're going to use that -1 again for the second synthetic division, guys. I'm going straight into it. So I'm going to drop the 1. 1 times -1 is -1. We add, we get -4. -4 times -1 is +4. We add, we get 8. 8 times -1 is -8. We add, we get 0. And again, that's expected. Now, guys, time to fill in those variables, starting with x squared followed by x. So now we have our quotient in the form of x squared minus 4x plus 8. And now we're going to go ahead and set that equal to 0 and solve it. All right, everyone. So I'm going to clear this out. X squared minus 4x plus 8 equals to 0. Now, let's go ahead and solve it. Perfect candidate for not synthetic division, completing the square, guys. So let's do it. By the way, it's not factorable. I know some of you are tempted. You want to factor it. You cannot find 2 factors of 8. That adds up to -4. That's impossible, everybody. That's why we're completing the square on it. So move the 8 over. So you get a -8. And then you're going to take half of -4. Or it's a +4. Okay, thanks for letting me know, Jessica. Thank you. All right. Scratch that -4, guys. This is going to be a +2 here. +2 squared is 4. So we're going to add that 4 to both sides. I'm adding the 4 to both sides. Why? Whoa, okay. It touches perfectly, but bounces into y-axis. +4. No, that was the answer after the -4. I'm sorry. Oh, so it is -4x? Okay. All right, so I'll change that, make it a -4. Okay, that's fine. All right, I'll fix it. All right, guys, so there we go. So let's factor. So this becomes x minus 2 squared. Take half of -4, take an x from the x squared. -8 plus 4 is -4. Now we're gonna finish solving this out. There's no negative right here, guys. There's no negative there. That's a pen mark. All right, take the square root of both sides. So we get x minus 2 is equal to plus or minus I. Oh, wait a minute. I'm sorry. I'm writing it the wrong way. As in 2i, because the square root of -4 is a 2i value, because it simplifies out. All right, guys. And now, to finish this out, what are we going to do? As to why we were able to use -1 again. Because, remember, Jessica, you said, no, that's Jessie. Because Jessica said when she graphed it on her calculator, it was bouncing, the graph was touching, bouncing at x equals to -1. So in the last video, I talked about how the graphs behave on the xy plane. If a graph, we talked about multiplicity, if the 0 has a multiplicity of 2, the graph is going to touch or bounce at the 0. Now, if a 0 has an odd multiplicity, the graph is going to cross at the 0. So in other words, when we talk about x-intercepts with these higher degree polynomials, there's a difference between a graph crossing and touching the x-axis. So when a graph touches at an x-intercept or bounces at an x-intercept, it means that that 0 is a repeated factor. It's a repeated 0. So it's representing 2 solutions. However, if the graph crosses the x-axis, it is an odd multiplicity or it's an odd 0, which means it's either representing 1 solution or 3 solutions. In the case of this problem, guys, the graph was bouncing at x equals to -1. That means that -1 is a repeated 0 of the polynomial. So that -1 was representing 2 zeros of the polynomial. Okay, Jessica, good. All right, guys, so I'm gonna finish solving this out by adding the -2 to both sides, or just take it and move it over to the other side. I said add -2, I meant add 2. So we get 2 plus or minus 2i. And just like that, guys, we are done. Now, we need to express the outcome, of course. So the outcome for this problem turns out to be 1 real 0, and then 2 complex roots, or 2 complex zeros. And that's it. Yes, guys, you will see this on the test. All right, I'm gonna do one last problem that you're going to see on the assignment. I haven't decided whether or not I'm going to put it on the test, guys. I'm thinking about it, but do pay attention to it. It says to write an nth degree. By the way, we're doing this backwards now. So they're going to give you the zeros, the solutions. And then you're going to have to come up with the polynomial that would produce the zeros. So here's the premise of the question. You have to write an nth degree polynomial if the zeros are I and for I. Now, also they tell you f of -1 is equal to 102. Now, they want this to be an nth degree polynomial, and here's the next part, n is equal to 4. So which means they want you to write out a 4th degree polynomial, guys. The polynomial has the following zeros, I and 4i, and plus at x equals to -1, the polynomial is at 102. So guys, what you have to understand is this. We have some factors here. X equals to -1, I mean some zeros, x equals to -1, x equals to 4i. And so what I want you to realize is this. These zeros are imaginary zeros. And these imaginary zeros, they always travel in pairs. So just like with the previous problem we just did, when we took the square root of -4i, we got a plus or minus 2i. So guys, if you have a positive I, that means you have a negative I. If you have a positive 4i, that means that you have a negative 4i. So basically each one of these zeros represents 2 zeros. So now the question you have to ask yourself is, okay, what is the binomial that would produce this 0? So for this one right here, guys, there's 2 binomials, x minus I, x plus I. Now, why am I doing 2 of them? Remember, these travel in pairs. So when you see a positive I, there's also a negative I. Same thing here, these travel in pairs. So if you have a positive 4i, there's also a negative 4i. So what are the 2 binomials that would produce those zeros? X minus 4i, x plus 4i. So what do we have here? We have conjugates. These 2 are conjugates. We're going to multiply them together. X times x, x squared. Here, let me erase that underline there. Okay, because I don't want to confuse you guys, okay? So x times x, x squared. Negative I times I, negative I squared. Now remember, I squared is equivalent to -1. So this would become x plus 1, okay? Now we're going to go over here and do the same thing too, guys, and multiply these 2 binomials. X times x, x squared. Negative 4i times positive 4i, negative 16i squared. Now remember, I squared is always equivalent to -1. So -1 times -16 gives you positive 16. So guys, this is the other binomial. Okay, we're not done yet. All right, so now guys, let me go ahead and write the form of this polynomial, because now that we know the 2 binomial factors that would lead to these zeros, we can use that to write out the polynomial. So let me write it out for you. So the polynomial would be in the form of the leading coefficient, which we don't know, times x squared plus 1 times x squared plus 16. Now, guys, listen, they want a 4th degree polynomial, as in, when you write your answer, it must be apparent that we have a 4th degree polynomial. You actually need to see the 4th power. I mean, you could leave it with x squared plus 1 times x squared plus 16. I mean, it's there, but you actually need to show the fourth power there, okay? Additionally, the a value, the leading coefficient, we don't know what it is. We need to find it too, okay? So guys, you've got a couple of options here. You could go ahead and find a right now and then multiply the two binomials later, or you could go ahead and multiply the two binomials first and then find the value of a. I find it easier to use the factored form, so I'm just gonna leave it like this and use this point right here, guys. Here, let me use a different color. Use this point right here to find the value of a. So in other words, I'm gonna go in and I'm gonna plug in 102 equal to a times -1 squared plus 1. Everywhere I find an x, I'm gonna substitute -1 in, square it, and then work it out. What am I looking for? The value of a. So now, guys, 102 will equal to -1 squared plus 1 is 2. -1 squared is 1. 1 plus 16 is 17. And then I am going to go ahead and multiply, so I get 34a. And then divide both sides by 34. Remember, I'm looking for the a value. And I think, guys, this comes out to 3. Check me on that. Does it come out to 3? Yeah, it does. Nice. So the leading coefficient is going to be 3. Okay, remember, I'm still debating whether or not I'm going to give you one like this on the test, guys. But this question is definitely on the assignment. All right, guys, this is the last problem we're working on. I'm going to erase this part so I can finalize the polynomial. I'm going to finalize writing it. So I'm going to go back in, substitute the 3 in for a, and then finish working it out, okay? So f of x will equal to 3 times, oh, let's multiply, guys. We're going to multiply x squared times x squared, x to the 4th, x squared times 16, 16x squared. 1 times x squared is x squared. 1 times 16 is 16. And then we add here. So we get 3 times x to the 4th plus 17x squared plus 16. Now we distribute the 3. So our final answer, people, remember notation is important, is 3x to the 4th plus 51x squared plus 48. Ooh, that's a horrible 4 right there. Shazam. There we go. That's better. So the question I'm asking you guys is this. If you see this one on the test, you're going to be okay with it? All right. So guys, yes, you do need to practice with this, okay? Remember, there's one like that on the assignment. Let me see. I don't have one ready for you, but I'm gonna have to stop because it's already 5:08 anyways. Listen, guys, I will do the one in the assignment for you, okay? You'll just have to find it in the assignment and let me know. I'm gonna stop here because I need to go on the calculator and show you guys a few things about the calculator.